Okay, here is the next example. Here we're going to solve this example. The question he's asking about, find the energy stored in each capacitor. Okay, so first thing, is this a DC circuit or AC circuit? How do we know that DC or AC? We can find out by using the source. Here I have a 60 volts DC source. How do I know that's a DC source? As long as you have plus and minus and with only voltage, only magnitude, no phase angle, then we'll say that's a DC source. Since this is a DC source, it's a DC circuit. What is the behavior of, so the question he's asking about energy stored in the each capacitor. So basically he's talking about the steady state. If it is transient state is nothing but immediately after switch is closed or immediately after switch is open. That's called transient state. Unless I specify transient state, you always assume that that's a steady state. So here we're going to assume this is a steady state. What is steady state? So the switch has been closed for a long time, so capacitor is already fully charged. How long does it take to charge the capacitor? Maybe a few milliseconds, maximum 1 or 2 seconds, based on the capacitance value. So here, so first thing, he's talking about the energy stored in each capacitor. What is the energy stored in the capacitor? Energy stored in formula, energy stored in a capacitor equal to half CV squared. So I have C value, so all I need to find V value. So let me take this as C1. I don't know why it is sliding down. Okay, I'm going to take this as C1. Here is C2. Okay, so what is the behavior of capacitor in DC? Once it is fully charged, capacitor acts like open circuit. So once capacitor is fully charged, it acts like an open circuit. How long does it take to charge the capacitor? As mentioned, probably less than a second. So I'm going to retell circuit with open circuit. So the circuit is going to look like this. Okay, so here is our V2. Let me take this as V1. Okay, why I choose plus on the top? Because I know this voltage, that's a positive terminal. So 10 ohm, 50 ohm, 10 ohm, 10 ohm. So if you look at this, is there any current passing through this 50 ohm? This 0 ampere, because it's open circuit. Current passing through the open circuit is 0 ampere. Okay, now so the current is going to go through the 10 ohms, another 10 ohms, another 10 ohms, and will come back. Whatever the current starting from the positive terminal, the same amount of current must reach the negative terminal. So I equal to 60 divided by 10 plus 10 plus 10, so 2 ampere. Okay, so 2 ampere current is passing through the circuit. Now if you look at the first 10 ohm, let me use different color. I'm going to label that as R1. Okay, and then R2, then R3. Okay, what is the voltage drop across this 10 ohms? I'm going to label that as V1. I'm going to label that as Vx. I'm already using V1. Okay, so what is Vx? Vx must be, can I say, I times R1, which is 10 times 2, 20 volts. Okay, so if there is a voltage drop of 20 volts, what is the voltage up here at this point? I'm going to take that as VA. VA must be 40 volt, because if I take this as a ground, the voltage here is 0 volt, the voltage here must be 60 volt, so VA must be 40 volt, because VA minus 60 equal to 20 volt. So I'm sorry, I mean 60 minus VA. and I label them wrong. Basically this is positive, that's negative, because that's a voltage drop. Okay, so 60 minus VA equal to 20 volts. So based on this, VA equal to 40 volt. Now can I say my VA and V2 are the same? Because VA is right there between these two terminals. V2 is also same because there is no voltage drop across this 50 ohms. So I can say my VA is same as V2, that is equal to 40 volt. Now since I know V2, I can tell energy stored in capacitor C2, energy stored in C2 equal to half CV square or C2V2 square, which is half 10 micro times 40 square. So half, that's 5, 1600 times 5. Use the calculator. 8,000. 8,000 microjoule, or I can say 8 millijoules. Okay. Now if you look at V1, okay, what is the voltage drop across V1? So can I say my V1 is same as voltage drop across R3? V1 is same as, because both of them are in parallel, voltage drop across R3. Okay, that value is 2 amperes times 10 ohm, which is 20 volt. So now I know V1, energy stored in C1, energy stored in C1 equal to half C1 V1 square. Half C1 is same 10 microcoulombs of 10 micro times 20 square, so 400 times, it's 2000 microjoules. Okay, so I mean 20 square is 400, 400 times 10, 4000, 4000 divided by 2, 2000 microjoules, or 2 millijoules. Okay, that's how we'll find the energy stored in the capacitor in DC circuit. Thank you.